Hello and welcome. This is the next video in my mini-series on discrete experiments, and I make this video for my students and also for some of you who asked me a question about the moderation within a discrete experiment and how to compare groups. I have already mentioned it in one of the videos. You can find it where I show how you can analyze different groups, and in this video I'm going to show you how to analyze the statistical significance between the groups, whether they differ or not. Just a short reminder, the data you see on the screen, I use this data for a study and we have submitted a paper recently. It is still under revision. That is why I am not able to share the data with you, but the logic is the same and you will be able to do it with your data. First, this is already a restructured file where we have the dependent variable, which is the final decision. It's either 1 or 0. It means the option is preferred or not preferred. And we have the independent variables, which are the organizational costs of digitization. These are the 4 levels. We have the personal costs of digitization. These are the 4 levels. We have the relational costs of digitization and the efficiency gain. These are our main independent variables. And in this experiment, I'm just going to show you one of the subsamples I'm going to analyze. I go to data and I want to select cases. In this experiment, we conducted the data collection between 3 main groups, between the users of digitization project, between the developers of digitization products and consultants. And we would like to compare the users against developers, so we don't need the consultants. I sort them out. This is the variable user developer, and it was 0 for the users, 1 for the developers, and 3 for the consultants. Consultants were just a small group and we skipped them in our analysis, and this is what we do now. So we click OK, and now we analyze not all the data but only the data coming from the users and developers of digitization projects. Now we need to compare the groups, and if you want to do it, we do it first of all without the comparison of the groups, just the all data all together. We go to regression, we make a binary logistic regression as our dependent variable is 0, 1, so it's binary, and we click on OK. And here we have a nice output. You see we have 2,180 cases to analyze. We have 2 missing values, and let's see the data. We come to the last stable variables in the equation, and you see that we have some significant results. We have the personal learning, so the cost related to teaching your personnel to work with digitization, they seem to be significantly different with regard to the 4th level, which has been sorted out. And it seems this option is preferred and is 1.9 times more preferable than the option without this learning than the other option which we have here. What else do we have significant? We have the tensions. These are the relational cost tensions among our partners, that they may have problem if we make digitization. They definitely is something we don't want to have. You see the odds that people go for this option are 0.775. It means the chance that people grasp to this option is lower than the 3rd option, which we compare here, which is the 3rd option is always sorted out, and the 3rd option was the problems due to incompatibility. This one, ill feelings because of digitization in our firm, and this was the tensions with the partners because of some other problems due to digitization. I can't remember exactly what were the formulations of the levels, but this is not important at the moment. So all data show that there are some significant differences, but we would like to see whether the groups differ, and for this we go to data, we go to split file, and we try to compare the groups. And we use the data, the variable user developer as our split variable. It means we will compare users against developers, and again, if you remember, I sorted out all the consultants. Click on OK, and now if I run the logistic regression again, exactly, there was HR costs were sorted out and internal discussions were sorted out. Okay, click on OK, and you receive now 2 tables. We have the users, which are 0, and developers, which are 1, and here they're compared. You see we have 1,618 decisions from users and 562 decisions from the developers. and we go to the last table, and we see that there are some differences. And look at, for example, the personal learning costs or personnel learning costs. They are highly statistically significant for the users, but they are not so significant. They are not significant at all for the developers. At the same time, the other variables, they also differ. We would like to know whether these groups differ in a statistically significant way. Because if they don't, we can say that they are more or less, they see it in an equal way. They would like to have the same preferences with regards to digitization project. If they differ, we can say that they differ with regard to what they do with their digitization projects. You do it in the following way. You go to the website by James Gaskin, which is the gaskination.com, and you go to statwiki.gaskination.com. By the way, he makes great tutorials on YouTube for statistics and structure equation modeling. I really recommend them to you. At least I learned my statistics using these tutorials. And James developed also an Excel stat tools file where he allows you to enter your data and calculate some interesting statistics. Here is the file. We click on activate working with the file, and we have here different tabs. Usually you use the validity master and the x2 difference and so on. We need the undefined group differences. This is actually what we need. And here, what we need to do is we need to introduce whom we compare here. These are the users, and these are the developers. We need to show the sample size, which is in our event. We go to the first table, and you see how many cases we have. 1,618 for users, and 562 for the developers. Now we need to enter the data here, and these are the logistic coefficients, and these are here the standard errors. You go to the last table, double click on it, and first we copy the names of the variables to we just know what we want to compare, and we enter them here. So it seems that we will not need the last lines. We just make them grayish, so they do not distract us. And now we enter the data here for the users. This is 0 for the users. We take the coefficients and the standard errors. We put them here, and we take the same values for the developers, and we paste them here. And it will automatically calculate for you the t-statistics and the p-values, and you can see whether the groups have some statistically significant difference. And it seems that we don't have anything statistically significant apart from 2 items which are close to the level of statistical significance. At least this one is very close. This would indicate that we have a weak statistical significance, or that we discovered a trend towards something. And let's see what are the differences. So with regard to learning, we have almost the statistical significance, and it seems that users put much more attention to learning costs for the personnel. So it seems that they would like to have this option. It seems to be more preferable than by developers. For the developers, they are indifferent, or they are less interested in higher learning costs for the personnel due to digitization strategy, digitization projects. And what we have here, it is the time which personnel needs to invest into a digitization project. And it seems that they even go into different directions. So while the personnel would like to invest time in this, it is a positive value, and this is a negative value. That's a clear indication that they don't want to have it. And it is weakly significant, so you can say there is a trend towards discrepancy between how developers and users perceive the personal costs of digitization, especially with regard to one item, which is the personnel time that personnel needs to invest in order to cope with new digitization strategy or with new digitization project. And this is how you do it. So take these values. If you want, you can mark them and make the formatting with the scales that you have. What was the correct one? Let's say the more greenish are the more statistical significant thing, and you see that everything which is green is lower, so we have at least two indications here that it is weakly significant, and yeah, this could be something in future. If you take also control variables into your model, maybe this would also become a little bit more statistically significant. And then you report the data. You report the values from the SPSS, how they are. You see the differences. You have the exponential b, what are the odds, what are the chances that people would prefer this option over the other option, which has been sorted out. And you see the statistically significant results here, but you also know now, with the help of this nice tool by James Gaskin, what are the differences between the groups. Do they differ statistically significant? It's in a statistically significant way. Look at the interesting value which I would like to show you. This is the efficiency gain. It is for both statistically significant, but there are no differences in this regard. Look how far they are. They're far away from the level of statistical significance. It means that the efficiency, as you see, the coefficients, they're very close to each other. It means that both users and developers value the efficiency gain that they can receive thanks to a digitization project, which is also a great thing you can tell about your data. So if it is not statistically significant, it can indicate that actually your theory is very strong and there are no differences between the specific types of users. For example, you can take gender, male versus female, and see whether they differ. And if they differ, this can be an interesting statement. If they do not differ, it is also an interesting statement. You say that they are indifferent in this regard. So, they are both interested, but there is no statistical differences between the groups. I hope you enjoyed it. Good luck with your research. Good luck with your statistical analysis of a discrete choice experiment. And I hope you can produce something pretty cool with it. Enjoy and bye-bye.